So simplify and rationalise the denominator, or whatever the question says. Question 3F, we're continued on exercise 223. So work this out, z squared minus 1 over z squared, and we want to give the answer as a rational denominator. So what have we got? Well, you know what you might want to do? Why don't you work out z squared on its own before you start on the side? Much better than working it out here and working it out there. You're doing all this doubling, working out. All right, so before we start, we're going to work over the side, and we're going to work out what z squared is. Now, z squared is 1 plus root 2 squared, which is what? 1 plus 2 root 2 plus 2. See, much better to do it over there. 1 plus 2 root 2 plus 2, which is 3 plus 2 root 2. Now, isn't that much better? So, much less working out, less room. So now, z squared is 3 plus 2 root 2 minus 1 over z squared is 1 over 3 plus 2 root 2. So now, that's what z squared minus 1 on z squared is. You can either choose to make common, look, we only want a rational denominator. We could probably just rationalise this second one without making a common denominator. So 3 plus 2 root 2 minus 1 over 3 plus 2 root 2 times what? 3 minus 2 root 2 over 3 minus 2 root 2. Which is, and I probably could have just done it on this line here. So it's 3 plus 2 root 2 minus, I just have to put a bracket, got to be careful here, because it's minus all of that. So put brackets, and what have you got on your numerator? Just the same, over, what's the denominator? So numerator is 3 minus 2 root 2. The denominator is the difference of two squares, which is 9 minus 4 times 2. 9 minus 8, which happens to be 1. Well, aren't you lucky? Which equals, the denominator is 1, so it's 3 plus 2 root 2. We know this is 1, minus bracket 3 minus 2 root 2. We okay with that? Because the denominator is 1. Let's go with 1. Equals 3 plus 2, you can actually just write your answer now if you want. So what have you got? 3 plus 2 root 2, 3, minus 3, so the 3's go, but you've got 2 root 2, what? Plus, we can write it all out. If you think you're going to make a mistake, write it all out. Minus 3 plus 2 root 2, which is 4 root 2. Okay? So whichever way you need to do it so that you don't make a mistake, that's the way you do it. All right? Okay, now the next one. Remember, I think we said we were going to try and, we can either multiply and then rationalise, or we can rationalise individually. But see, if we rationalise individually and we come up with different denominators, we still have to find a common denominator. So, you know, the very first time I did this on the video before, we made a common denominator first. Let's try separate this time, see what we prefer. All right? I'm going to rationalise each one separately, but I think this may be more work. So times root 3 plus root 2 over root 3 plus root 2. So I'm going to keep that in brackets, minus the second fraction, 2 plus root 3 over root 3 plus 1 times root 3 minus 1 over root 3 minus 1. Okay. Okay, yes, I didn't put square root 2, from the question. Thank you. All good? Yeah, I missed that square root 2. So we're rationalising each one separately, and then let's just see how this method goes. So what have we got? Root 15 plus root 10 minus root 6 minus 2 over root 3 squared is 3 minus root 2 squared is 2. So this denominator is 1 minus this next one, 2 root 3 minus 2 plus 3 minus root 3 over, what's this second denominator? Root 3 squared is 3 minus 1. So this second denominator is 2, but we still need to do some simplifying first. So the first one, my denominator is 1, so I don't need to put a denominator. So it's root 15 plus root 10 minus root 6 minus 2 minus, I'm going to keep this all in brackets at the moment because it's take away all of that. So what have I got? 2 root 3 minus root 3 is root 3. What have I got here? Plus 1 over 2. Are we okay? Minus all of this. Keep it in brackets. I've got root 3 plus 1 over 2. What should I do now? I want to write this as one fraction. I'm going to multiply this first bit. You know how this bit is actually over 1? I'm going to put the 1 back. Because I'm going to multiply this first fraction by 2 over 2. So I've got 2 root 15 plus 2 root 10 minus 2 root 6. Remember, I'm multiplying by 2 over 2. Minus 4. This is over 2. But this other fraction's also over 2, so I'm going to continue. Minus what? Minus root 3 plus or minus 1. Because it's minus that. So if I go minus bracket root 3 plus 1, I'm going to write the same line again and just write, and then I'll open the bracket next. Because it's minus root 3 plus 1. Minus root 3 minus 1. Okay? Now, is there anything that can be simplified? Minus 4 minus 1, you've got to make it minus 5. And that's it. Alright, so now we need to write another line. I don't think I'm going to fit. 2 root 15 plus 2 root 10 minus 2 root 6 minus root 3 minus 5 over 2. Now, you're lucky that 10, 6, 15, root 3, you can't simplify any of those surds. Alright? Oh. Right. Question 4. Find A and B. What do you think you've got to do? See, A and B, there's no denominator there, so we're going to have to rationalise. Oopsie, sorry. So let's start with our left-hand side. Root 2 plus root 3 plus 3 over root 2 minus 1. So we're going to multiply that by root 2 plus 1 over root 2 plus 1. I'll just give you a minute to do that. Root 2 times root 2 is 2, plus root 2 times 1 is root 2, plus 3 root 2, plus 3, over root 2 squared is 2, minus 1 squared is 1. Collecting like terms, we've got 5 plus 4 root 2 over 1. It just happens to be 5 plus 4 root 2. That's fine. That one's an easy one. So therefore, what does A equal? 5 and B is 4. But see, A and B could have been fractions as well, hopefully. Oh, yes, I'm wrong. Thank you. Very good. So, yes, it's just A plus root B, not A plus something root B. So it's 5 plus root 16 times root 2, which is 5 plus root 32. Now it's in the form of A plus root B. Good idea to write that underneath. Then you won't make the mistake I did. Therefore, A is 5 and B is 32. You've got to be careful. You just need to look at the format in which it's written and not assume, as I did. Simplify. If x equals root 3 plus 2, simplify x plus 1 on x, then we'll do x squared plus 1 on x squared, which is like one we did before, remember? And there's another one to do x plus 1 on x all squared. So let's go. What's x plus 1 on x? It's root 3 plus 2 plus 1 over root 3 plus 2. What do we do? Rationalise just the second one. So we rationalise the second one, which is root 3 plus 2 plus Well, the numerator is root 3 minus 2, and the denominator is 3 minus 4. I'm just going to move this next one down. Which is root 3 plus 2 plus, what's the denominator here? It's negative 1, isn't it? So you can write it as root 3 minus 2 over negative 1. So I'm just taking too much room. So what does this become? Root 3 plus 2, what's this going to be? Minus root 3 plus 2. Okay with that? Because root 3 divided by negative 1 is, or you can just bring that minus up there. Alright? So what have we got? 4. So x plus 1 on x is 4. Next thing is, wasn't it x squared plus 1 on x squared? So working that out. What have we got? Do you want to work out your x squared first like we did the other time? It did save us some time. So x is root 3 plus 2. So just over here, I'm saying x squared is root 3 plus 2 all squared. Good idea to work it out first before we start. Which is 3 plus what? Plus 2 times that, isn't it 4 root 3 plus 4? So x squared is 7 plus 4 root 3. And once you've done that, you can come back over and work out your x squared plus 1 on x squared. So that is, I'm just going to put this 4 over here. Seven plus 4 root 3 plus 1 over 7 plus 4 root 3. So now you can rationalise. We've done something like this before by multiplying by 7 minus 4 root 3 over 7 minus 4 root 3. And we get 7 plus 4 root 3. I'm going to put this in brackets. Plus 7 minus 4 root 3 over what? Isn't it 49 minus what? 49 minus 16 times 3, which happens to be 48. Isn't that great? So it's 7 plus 4 root 3 plus 7 minus 4 root 3 over 49 minus 48 is 1. So we can lose the 1. And what's our answer? 14. And the last part of the question is to calculate x plus 1 on x all squared. Wasn't it? Yeah. What do you know already? We can do this a couple of ways. Was that? I think that is the question, x plus 1 on x all squared. Using our AMP to work this out, we know what x plus 1 on x is from part 1. It's 4 from part A. So it's just 4 squared, which is 16. The other way, you know how if you hadn't done part A and you had only done, say, part B, all right, there is a relationship between x plus 1 on x all squared and x squared plus 1 on x squared. Let's say you hadn't done part A. The other way to do this is as follows. X plus 1 on x squared, isn't that x squared plus what? Plus 2 times that, which is what? Plus 2 plus 1 on x squared, right? So this is another way of doing this. Do you know the answer to x squared plus 1 on x squared? Look. So isn't that x squared plus 1 on x squared plus 2? I've just rearranged. What's x squared plus 1 on x squared from part B? 14 plus 2, which is also 16. So just showing you two ways of doing that. All right, so you would do the second method if they did not ask you to work out x plus 1 on x in the first place. All right? So let's say the question was just find x squared plus 1 on x squared. You got that, hence find x plus 1 on x all squared. You'd use the second method. I've used the first method here because I know what x plus 1 on x is. And just this last one, question 9. If 2 plus 1 on x equals root 3, find x as a surd with a rational denominator. I don't like the way that looks. So, why don't we just rearrange it? What have I got? 1 on x equals root 3 minus, guys, 2. I still don't even like the way that looks. Why don't I swap root 3 minus 2 with the x? So 1 over root 3 minus 2 equals x. Rationalise that now. See what I've done? Okay. So I've just swapped, or I've multiplied both sides. No, I've swapped. Cross multiply, half cross multiply. So I can multiply by x and then divide by root 3 minus 2. It's like when you're solving trig. You know when you're solving trig and you're trying to find something on the denominator? Are we okay with what I've done there? So now, therefore, x is 1 over root 3 minus 2 times root 3 plus 2 over root 3 plus 2, which is root 3 plus 2 over, isn't that 3 minus 4, which is negative 1. So we just divide both terms by negative 1, and you get negative root 3 minus, minus 2. And that's it.